ready. Correct? So let's talk about performance analysis. Suppose from the DMA, you're copying an amount of data from SRAM to the DDR IP. From the DMA, you are copying from SRAM to DDR. Okay. Okay. So talking about the performance analysis, it's been done in a time window. Okay. In a time window, we will check how many times ready, valid handshake happened. Okay. Within a time frame, how many times the ready, valid handshake happened. Ready, valid handshake happened means, suppose if we take a clock, I need to open paint. Okay. I'll draw clock for you. This is good. Okay. This is the beautiful clock pulse. Okay. And suppose this is the valid that is coming from the master. Okay. And during this time, the ready is asserted like this. Okay. So during this time window, यार किसी से माउस मिल जाए, माउस दे देना यार कोई भी अपना एक. 1 minute. गोलू नीचे जा रहे हो, लीला जी से सेल ले आना इसके लिए. Give me a minute, yaar. My mouse is not working. Okay, guys. So what we do? I mean, this clock is coming from, I mean, infinite time, and it's going to a long time. Okay. So what we do? We choose a time frame. So we want to calculate the performance between this and this. Okay. At what time ready and valid handshake happened? So ready valid handshake happened at this point. At this point. Meeting 3. Okay. 4 and 5. So out of 1, 2, 3, 4, 5, 6, 7, 8 clock cycles, the ready valid handshake happened for how many clock cycles? 5. So how much time we utilize the bus? What is the performance? 5 divided by it into 100. So when you will 5 divided by it is 62. So it would be 62.5%. So what is the performance of this? It's 62.5%. You understood how we calculate the performance? That within a valid time frame, how many times ready valid handshake happened? Ready valid handshake is happening. It means we are utilizing the bus. Okay? We are utilizing the bus. So if we are utilizing the bus, it means okay. We will check how many times ready valid handshake happened. This will tell us about this will tell us about bus utilization. Okay. That how much time the bus has been utilized. So usually we used to calculate performance like this only. So we take thousand of clock cycles or 2000, 5000 clock cycles, and within those 5000 clock cycles we'll see that, okay, that how many times the ready and valid handshake is happening. Okay, master will continuously send the transaction, so you can see that valid of the master is always high, but depending upon the FIFO size inside the slave, that how the slave is behaving, so slave will toggle the ready depending upon the availability in the FIFO. You know how the ready behaves, right? Depending upon the availability in the FIFO, it will just slow down the ready. So let me explain in a much better way how this is also. So suppose this is a master, this is a slave. We know that inside the slave there might be many FIFOs that are used to temporarily store the data. Okay. Suppose the depth of the FIFO is 10, and this is an interface, a ready valid interface that's been connected, and slave is sending a transaction over here. Okay, I mean at this point the frequency over here is suppose 2 gigahertz, and the frequency over here suppose is 1 gigahertz. Okay, so master will continuously send the transaction, but here the transaction is slow. So and the depth of the FIFO we have taken it as 110. So at some point of time it will happen, the FIFO will get full. Okay, the master is sending the ready valid signal continuously, because master will continuously send the transactions. But what will happen at some point of time, ready from the slave side will get deasserted, and until and unless these the transaction are popped out and there is a space in the FIFO, then only the ready will get high. Okay, so this performance analysis, what it is doing, it is helping us to calculate that how much time we are utilizing the bus. Okay, and what should be the minimum depth of the FIFO that we can take over here. This is the slave and this is the master. Got me?
Yeah, got it, sir.
So this is basically the performance analysis. Okay, now talking about one more point that I mean, this is the basic of performance analysis, and I think this is okay for you. If someone asks you, have you done the performance testing, you can say yes. So what you will do, you will generate valid from the master continuously, and during the time frame you will check that how much time a ready valid handshake happened. Okay, so by that way you can calculate the performance. The second point that I would like to cover is the back pressure testing. So usually what happens, there is a master, I mean this figure now we are much familiar, there is a slave and there are a lot of slaves that are connected over there, right? And this is the master. Suppose this is green is the valid one, and suppose red one is the ready. That the assignment that I had given you, we will play with this ready valid, we will calculate the performance, everything we will do in that. That's why I've given you that example to do. Okay, green one is the valid and red one is the ready. So ultimately what is happening, this is a NOC, network interconnect. So while doing back pressure testing, what we will do, we will pull down the ready. We will pull down it from one of the master. Okay. Okay. And then what we will do, we will target the transaction from this slave to this slave, this master to this slave. Okay. There might be FIFOs inside it. So if we will pull down this ready, this FIFO will get full at some point of time, and then this FIFO will lower down this ready. Because you are continuously sending the transaction, but slave is not ready to accept it. When slave is not ready to accept it, there is the FIFO inside the knock, and that knock FIFO inside the knock is getting full. So ultimately is pulling down this ready, and master is getting back pressured. Okay. So first of all, we need to check. Huh?
Can you explain again?
Oh, explain it again. Okay. Green is the valid, red is the ready. So ultimately, what is happening? Master is sending the transaction, and suppose it is targeting this slave 1. Okay. So what we will be doing from the master side, we are sending the transaction and we are targeting slave 1. We will forcefully pull down this ready. By force, we will pull down this ready to check how the system behaves when one slave is hanged. Okay. Suppose this slave is not responding and the ready of the slave is not high. So ultimately, your master is targeting this slave. It will continuously raise its valid high, and it will ultimately wait for the ready, but ready is continuously low. So ultimately, there is a FIFO inside a knock. So suppose the depth of this FIFO is 5. So ultimately, after 5 transactions, the ready that is coming from knock to master, this will also be pulled down. Correct? And now your master is hanged. So first of all, we need to check that whether the back pressure from each slave is coming towards the master. If that is happening, that is wrong. That should not happen, right? Because suppose okay, suppose if ready of this slave, I mean, I'm marking it this in purple. If this ready is low, okay, and your master is targeting, suppose this slave, it's targeting this slave, okay, it's targeting this slave. So if this is low, this should not affect this. I mean, slave ready should not affect the ready of the master. During back pressure testing, ready of one slave should not affect ready of other slaves, yeah, masters. Okay. Suppose if one slave is, this means your one slave is hanged, right? If one slave is hanged, the back pressure should not be created on any other slave. I mean, master should freely access other slaves. Okay. So if the back pressure is coming from slave 1, it should not be affecting slave 2, 3, 4, 5. So by this kind, I mean, we do some back pressure testing. We just force the ready. We can take the ready of any of the master and we can check that, okay, that the ready, if the ready of that master is or slave is pulled down, it should not affect the master side. Got it?
Yeah, got it, sir.
Okay. So this is a very basic of this back pressure testing, how we are doing. Okay, and this back pressure testing being done for all master, and we should try accessing all the slaves. Okay. रिव्यू मुस्कान बाहर ले लो ना यार, दोनों लोग बाहर चले जाओ, लंच वाले टेबल पे बैठ के ले लो. Okay. EXI attributes from all master. This is also a very basic topic. So ultimately, suppose this is an EXI master, and during the EXI class, we have already told you about EXI attributes like AW address, length, valid, cache, prot, user, right? So there are many EXI attributes. So there are multiple master present inside the slave, right? Inside an SOC. So what we will do for each of the master, we will check that all the AXI attributes are tested. Okay. So for each master, we need to check all AXI attributes are tested. Okay, guys. So this is basically for, we need to check that all masters can access all the slave. All masters should access all slaves with all the possible or valid AXI attributes. Okay. So you understood about the performance, how we calculate the performance. You understood about this back pressure testing, that how we are forcing the ready, and that ready of one slave should not impact the ready of the other slaves.
Yes.
Okay. Effective verification techniques. Okay. So this is also very debug is not of important. We'll take separate class for this debug. Okay, coverage we talked about, right? Toggle coverage and all the coverage items in that PPT it has been written. Bug reporting and tracking is very basic. I mean, how do we report bugs in SOC? So that I will explain you. Hopefully, I mean, we have covered many things, everything almost. Okay. So any doubt? Because from tomorrow we will be discussing some real case scenarios. Okay, some bugs that you, or we'll discuss about AXI protocol, because I think customer is asking too much on AXI, so you should be able to understand the AXI protocol. Any questions? Anyone? So everything is clean?
Wait, sir.
Yeah. Ma'am, you're asking something?
Can you go again with the example that you roll a master with 5 slaves?
What? Which example?
The example you roll a master with 5 slaves and not between.
Yeah, this one?
Yeah.
Mm-hmm.
So I
So
also have a doubt in back pressure testing.
Okay. Mm-hmm. Yeah, ma'am, you complete first.
so I want to ask that how if the only the first slave is not respond because the valid of it, how it make the whole system hang, sir?
Mm-hmm.
Because I
The
think
whole
they
system should not hang. That is the,
yeah.
we
Okay.
need to find out that the whole system should not hang. If suppose one slave is unresponsive, the whole system should not hang. That is the main criteria. Okay.
Okay, sir. So in the test, we will pull one, for example, the slave
Yeah.
one, we pull it
What
low.
you will do, you will, yeah, pull the, in the test, you will force the ready of one slave to be 0, and then you will fire the addresses of other slaves, and nothing should hang. Okay. One slave should
Okay,
not
sir.
back pressure other. Your knock should be capable enough to handle this. Yeah, Molly, you were asking something?
Sir, I was saying that ready to use your hard coding, and can we do that for like two slaves or multiple slaves at a time? That only
Molly,
one
your
slave
voice
is
is
active
not
and
at
other
all
slave.
clear. Your voice is not clear. Can you repeat again? Are you in
Sir, am
office?
I audible now? Hello?
Are you in office?
Sir, I'm in the road of office.
You are in the road. Okay. You are just reaching office. Okay. Now, can you ask your question again?
I was asking, like in graph pressure testing, you said that
Mm-hmm.
we'll hard code the ready signal to be low
Mm-hmm.
for one slave. Can we do that for multiple slaves that at a time
Yeah,
only
you
one
can do
slave
it.
is
You
active?
can do it for one slave, two slave, three slaves. The main motive of this back pressure testing is, if we are pulling down the ready of other slaves, it should not affect other slaves. If we are pulling the ready of, suppose 1, 2, 3 are not responding, then it should not affect 4 and 5. You should be easily able to access 4 and 5.
Excuse
If
me,
that
sir.
is happening, you have pulled down the ready of 1, 2, and 3, so they are not responsive. Okay. and you're targeting 4 and 5, and your transaction is getting lost or getting hanged, then there is a problem. That should not happen, right?
Sir, but like my doubt is this only. Every
Mhm.
slave would be present in different address range.
Yes.
So, like, how will that, like, one slave would be affecting other? Like,
Knock, the knock design actually. There are several
oh, depends
parameters.
on the knob design. Okay.
Yes,
ठीक
that's
है.
why I mentioned knock over here.
हाँ, okay, sir.
Knock
Okay.
should be capable of handling that, right? Handling
All
that
right.
backpressure.
Yes. Yes. Okay, sir. Got it.
More questions?
Hello.
Yeah.
Sir, sir, actually, I have one question. Like,
Yeah, Kushal.
in that especially testing, you're saying, right? Like the FIFO will, if the FIFO is full, then the ready will get low, right?
Ready will get low. That's what that should not happen. That's why after explaining that, I told you that should not happen. If the FIFO one slave is getting full, it should not affect other slaves. Okay.
Yes, sir. Like
Ultimately,
it will
this the
not.
back pressure from here should not, the back pressure from this slave. Let me take a big brush. Okay, the back pressure from this slave should not affect this.
Yes, sir. But yes, sir. But like in case of knock, right? There will be a FIFO inside knock, right? So
Yeah, there's several FIFOs,
uh,
not only one FIFO.
yes, sir. And when the FIFO,
Depending upon the outstanding you are supporting. Okay.
yes, sir. And when the FIFO is full, then
Uh-huh.
the knock will low its ready as well, right?
No, that should not happen. That's what I'm telling, right? After explaining everything I told, that should not happen. The FIFO might be, there are several FIFOs, right? But
Yes, sir.
if the FIFO of this slave is getting full, I mean, so it should not back pressure this ready, right? If you're targeting this, it should not happen. I mean, the ready should not get low of master. And suppose if one is not responding and you want to access 2, 3, 4, 5, then you should be able to handle them. This, the ready of
Mm,
this, of the FIFO is getting pulled over here. It should not affect this. Not affect. After explaining the scenario, I told it should not affect.
okay.
Otherwise, what
Okay.
will be the problem? If suppose one slave is not responsive, your whole system will get shut down, right? Whole mesh is
Yes, sir.
getting. So this kind of testing we usually have to do while verifying the SOC. So these type of attributes of back pressure testing, that forcing the readies from random locations and accessing other address spaces. So nothing should hang inside an SOC.
Okay. Okay, sir.
Actually, what happens, right? So there are several timers. Kushal, I
Yes,
will
sir.
tell you the solution. Now your question should come, why then suppose the ready of one is low. 1 minute. I'll take new. Okay. For an example, another example I'm taking. I mean, that will give you a better idea. Everyone is with me? So
Yes,
I
sir.
don't know whether you have heard about it or not, but I'll explain you with another beautiful scenario. We are connecting all the slaves like this, right? Suppose this is the valid, and we'll take some good color, the size of the brush with green. So this green is ready, okay? And we'll take this dark blue. Suppose this ready is low, okay? This ready is
Yes, sir.
also low, and these two slaves are working. Okay, so ultimately 1, 2, 3, 4, and this is your suppose master. This master is CPU. Please listen this scenario carefully. These type of scenarios usually come. I mean, interviewer and usually comes when you are verifying the SOC. Okay, my friends from Vietnam, you are listening it, right? So ultimately,
Yes,
what
sir.
will happen inside the while designing the knock, we implement a drain mechanism. What we implement? A drain mechanism. Okay. So ultimately, what will happen? Suppose if your this ready is low, the first transaction that you targeted is coming from, yeah, it's coming. Oh, I will take some orange color. Okay, it's coming from here, and you are targeting this. This targeting it. This is getting response back. Okay. The second transaction that you are targeting is like this, and this is also getting the response back. Correct? The third transaction that you targeted is for knock 1 and it does not give you the response back. Okay, because knock is waiting, because here what is happening, knock is getting the response at this point and it's propagating it to the master side, but here you're not getting the response. So there is a drain mechanism usually implemented. Drain mechanism means it's like a counter that you will configure it for suppose 2048 clock cycles. That okay, if I have sent a transaction towards slave 1, so drain mechanism for this at this point, drain mechanism at this point, drain mechanism at for this slave, drain mechanism for this slave. So if the response is not back from 2048 clock cycle, okay, if the response is not, I mean, arrived for 2048 clock cycle, what it will do, it will just give you a slave error as a response. So ultimately response have not arrived at this point, this slave is hanged, so drain mechanism will be active. Okay, and what will do, drain mechanism will give you the response back. So ultimately master is not hanged, it got the response. Master is hanged in that condition when it doesn't get the response. Got it?
Yes, sir.
Yes, sir.
So
Got it,
usually we have this
Yes, sir.
timeout mechanism. Someone used to tell timeout mechanism. Someone used to tell drain mechanism. Okay, just note it down. Drain and timeout mechanism. So you might have a timeout mechanism. Okay, you will have a drain mechanism. So these two type of mechanism will give you the response back, and the response will not be okay. It is configurable, but usually it's a slave error. Usually it's a slave error. More questions? Now I think now it's much more clear, right?
Yes.
So SOC should never hang. Keep this in mind. And this type of scenarios usually given by the interviewer, they will ask you to draw this and will ask you. So you will explain that I found these bugs. So what is happening when we are just lowering down, it's ready, the whole knock is getting hanged because this drain mechanism was not working properly. So we have a drain mechanism for each and every slave. And when this timer, this is a configurable value. When this is getting expired, it's giving out a slave error. And this slave error is also configurable. There is a configuration register inside the knock that tells us whether we want to give decode error, slave error, or okay response. Okay. More questions? More questions? So ultimately, this diagram that I have shared with all of you, right? So if you will code this, what we will do, we will make this ready low and we'll try to access it. We'll make that ready low and we'll try to access it. So this thing will give you a real-time idea that how an SOC is working. We'll calculate the performance. We'll send thousands of transactions towards each slave, and we'll see how much ready valid handshake is happening. We'll change the frequency. This interconnect is working on 2 gigahertz, and this is working on 500 megahertz. This is working on 1 gigahertz. So ultimately, this is slow, right? And we will continuously send transaction. We'll check how we are handling that. Getting NAM trunk tree NAM.
Okay, sir. But I have a question.
Yeah, ask question. I'm here to help you out.
So, for example, if from the ISI, you read data out from the memory, okay? So you send the address of the memory, but go through the knock, it go to the other address and it read the data out. How can we check that we read the data correct or not?
तो शायद कुछ समझ में आया क्या क्वेश्चन पूछा? Can you explain? Ask again. Actually, your voice is breaking in between.
Okay, like for example, the 1, 2, 3, 4 is the address inside the memory. You send read to address 1, but through the knock, it go to address 2 and read the data out, and then it send back to your ISI.
Okay, so you are asking about the scoreboarding. I'll tell you. Very easy, and it is asked many times. Suppose this is a knock, this is master 1, master 2, master 3, master 4, master 5. Okay, so this is the master 1, blue color. This is the master 2, this is the master 3, this is the master 4. Its ranges from 0100. Its range starts from 0200. Its range starts from 0300, and its range starts from 0400. Okay, and this is the master, and from this master you are accessing these slaves. Okay, so
Okay,
Nam,
sir.
you were asking about these things. Suppose if you are targeting address 0100, okay, and there is a bug that this should reach on first, but it is reaching on second and responding you back, right? It should
Yes.
reach first, but it's not reaching here. It's reaching here and giving over the read data wrong. So ultimately, what is happening? You will create a scoreboard. Okay, this type of problem can easily be solved by the scoreboard. So what will happen? You will place AXI monitors. These are the AXI monitors. Okay, so these are placed on each and every interface. Okay, so what you will do, Nam, to verify it, you issued a transaction from the master. So the transaction address is suppose 0100. Okay, you pushed it in a queue. I mean, I'm just telling you how the logic has been written. You expected queue. You will expect this transaction to reach at this slave, right? Expected queue of slave 1. You will push this transaction into this. Through analysis port, you are getting this inside your scoreboard. Okay, but the transaction is not reached over here. You know this. Okay, this is the address, and this address is targeting slave 1. So you are storing it in a queue of slave 1. Okay, but it's haven't reached slave 1. Instead, it reached slave 2. Okay, but there is no outstanding request for slave 2. Is there any request for slave 2 that you have raised? No. And suddenly a transaction arrived over here. So you will check expected queue of slave 2, but that is empty. So it's an error. You got an unrecognized transaction at slave 2, which has not been targeted by masters. Okay, so there might be many masters. So what you will have, depending upon the number of slaves, you will create some expected queues, and when the master is initiating a transaction, you will store the transaction in the expected queue of that particular slave. When the transaction is reaching to the slave, your XI monitor will give you that data from analysis port that I have received one data. So you will check the expected queue of that particular transaction. If the transaction is over there, you will say yes, okay, it's a correct transaction. If it's not, then it's a bug.
Okay, sir.
So
But
ultimately, these type of scoreboards we need to have while verifying SOC at the SOC level.
but what I mean is because did error it because the not it make the error. So for example, if the slave 2 it request it give the response, but true does not, it become the slave 1.
What I am not getting you. Can you explain? Ask
What I
again.
mean what I mean is if the not
Mhm.
is routing wrong, the routing is wrong from the NOC.
Yeah, so NOC
Because
routing is wrong. Then you will
yes,
get this kind of a scenario, right?
because the response from slave 2 it becomes slave 1 and you cannot detect that.
Why can I not detect that? I have told you I can detect it, right? I am targeting this address. This address should, I have taken the queue for this, a queue for this, a queue for this, and queue for this, expected queue. If I am sending this transaction in my scoreboard, okay, I am storing this is 1010. I will push it in this queue. This queue have now this transaction. Q0 is empty, this is empty, this is empty, and I'm getting a transaction on this. I will check this queue. This queue does not have any transaction. So ultimately, what is happening? There is a bug. There is a bug. I can check that, okay, there is no transaction over here in the expected queue because I am storing the expected queue from here. When master
Okay,
is sending the transaction, I'm sending the storing the in expected queue, and when it's coming, I'm checking it out that whether it have.
uh,
But since it's stored in expected queue of 1, This is a bug. Understood?
Okay. Yeah, got it, sir.
I mean, it's very basic scoreboard. So now it's my turn to ask question from you. Okay? Will you be able to answer?
I'm ready.
Ah, great. That's the spirit. Okay. So now, okay. So now there are two masters. This question is not only for NAM, it's for everyone. Okay. And let's take, since NAM, I will ask you a very small question, a basic question. Okay. A red master is there. Oh, sorry. Orange master and green is there. Okay. So this is connected to, this is connected and this is connected. Okay. This is slave. This is master and this is master. This is master 1 and this is master 2. And the address range of this slave is from 000 to FFFF. Okay.
Okay, sir.
Okay. And you have a, okay. You have put it an EXI scoreboard over here just to monitor at what is happening over here, and you can put an EXI scoreboard over here to monitor that okay, this master is getting all the data and everything correctly. Okay.
Okay, sir.
You're accessing address 0, some data is coming, and when you are reading it back, you should get the same data out, right? Okay, now. So suppose, I think it's very easy for you, so you can answer it. So suppose if you're targeting address 0000 from master 1, okay, and you are writing a data 1, 2, 3, 4. This is the right.
Yes.
Okay. When you are reading from master 1 only, okay, the address 0000, what data you will get?
1, 2, 3, 4.
1, 2, 3, 4. So you will say that okay, this scoreboard is working fine and your test is getting passed. Okay.
Yes.
So now from this master, suppose if you are writing address 0000 with a data of ABCD, the transaction will go like this. And when you are reading it again 0000, what data you will get?
ABCD.
ABCD, very good name here. Okay.
Right.
Then after that name, what you are doing, you are again reading it from slave master 1, the address 0000. What data it will get?
Now it become ABCD.
AB,
ABCD.
ABCD. Okay. But your scoreboard expects 1, 2, 3, 4 because it had scored that. Okay. And here you are getting ABCD. So your test case will pass or fail.
Yeah, we fail.
So how you will tackle the situation while coding the scoreboard?
So I think if the masters from 1 or 2 from both the master, if any master send the right transaction to the same directory, the scoreboard should update from both.
So suppose NAM there are thousands of masters connected. So you will update all the 1,000 masters memory or 1,000 scoreboards.
And they should use the same scoreboard.
Okay, so the answer is they should use not the same scoreboard, not the same scoreboard, same memory.
Yeah,
correct. So ultimately, what should they use to store the data? So you will take a verification environment memory, a common memory. So whenever you are reading and writing, you will update this memory as well. Okay.
Yeah.
This is a very important question usually asked. But how do you tackle this situation?
We will use the same memory like this to store the data when we write.
Data the master is sending. So same memory in the verification environment will help you out with that. Okay.
Yes, sir.
Everything is clear to all of you, or you are just sitting and wasting your time and mind time as well? Because apart from 2-3 people, no one responds.
I think today it's okay, sir. You on mute, sir.
या संजीव एंड यशपाल, समझ में आया आपको?
हाँ जी सर।
हाँ सर।
पक्का ना?
यस सर।
यशपाल, these type of questions will come. And I think you will, जैसा मैं समझा रहा हूँ ना यशपाल, you should be able to explain this, okay? Performance, back pressure, क्या क्या टेस्ट किया आपने नॉक में? Okay. Questions, more questions.
सर एक चीज थी, can we say कि like we have different types of test cases in while verifying SOC. So can we say कि this back pressure was one of the test cases, or it will come under register because we are
Back
anyways
pressure
reading
is
it
a
again.
feature. Back pressure is a feature.
Okay,
And
is a feature. Okay, ठीक है.
it's a feature and it have more than 50-60 attributes to test.
Okay, ठीक है.
That you are making the ready of DDR IP2 below and you are testing PCI IP2 below, multiple IPs together. So it's a subject and inside it many attributes can be there, okay?
Okay, sir.
More questions, my friends? Woo, you are silent today.
Yeah, I think it's clear, sir.
Yeah, now you are an SOC expert. If you have attended all the classes, so you should have known about SOC.
Yeah.
प्रज्वल, खुशाल, आपको क्लियर हुआ?
हाँ सर।
Yes, sir.
Ujjwal is not here in the meeting. I don't know. Ujjwal never joins. कल भी नहीं था Ujjwal. Ujjwal is on leave, right?
सर मंडे ट्यूसडे लीव पे था वो.
हाँ, मंडे ट्यूसडे, कल भी नहीं था वो. पंकज.
हाय सर.
हाय पंकज, कोई डाउट है यार इसमें और कुछ ऐड ऑन करना चाहो आप? आपने तो काम किया हुआ है यार.
जो इसमें hazards का मुझे पूछना था कि hazards कब आएंगे पिक्चर में.
Hazards तो देखो क्या होते हैं, रीडिंग एंड राइटिंग ऑन सेम एड्रेस. Hazards. So hazards are basically raw, read after write, write after write, write after read, read after write हो गया ना, read after write, write after write, write after read. Yeah, these three types of hazards basically.
Sir, read after read भी होगा.
Read after read nothing matter नहीं करता उतना. Hazards always comes when we are having a write. Okay. So ultimately, I will. Okay, you want to understand hazards? I'll explain you. Okay. Suppose this is a master, and as we know, AXI have a separate bus for write and separate bus for read. AXI have 5 channels. Everyone know?
Yes.
So suppose this is your black one is your write channel and this is your read channel. So in AXI, AXI write and read are independent, right? Pankaj?
Yes sir.
Suppose if you're working on DDR.
Okay.
It will come a write and it will एक write आया, एक read आया. They can come at the same time. Okay?
Okay.
And this controller have all the ability. Because controller जो DDR पे भेजेगा that will also be write or read, correct? कि वो write भेज रहा है command या read भेज रहा है. ठीक है? So if suppose on the same clock cycles, a write and read is coming. On the same clock cycle, write and read both are coming. This can happen, right? Because these channels are independent of each other. Okay?
Okay sir.
And on this write, Pankaj, आपका एड्रेस था 0000 एंड आपने डेटा लिखा है इस पे ABCD. ओके पंकज?
Okay sir.
ओल्ड मेमोरी में इस एड्रेस पे डेटा स्टोर था 1 2 3 4.
Okay.
Okay, and you have a same, you have the read at the same clock cycle. आपने write भेजा and you have the read at the same clock cycle. Okay?
Okay.
So what should be the read data?
ABCD.
क्यों?
Because राइट
Why
भी हम
ABCD?
उसी ट्रांजैक्शंस पे करा रहे हैं.
No, it shouldn't be ABCD. That is the hazard handling.
Okay.
You see, because you have sent a write, but you have not got the response back of it from the slave, right?
Okay.
So this is called read after write hazard. You should take care of that. It should not happen, right? Because we are still not sure. We are still not sure that the write has been accepted by the controller. When we will get the response back, if suppose response is coming in this clock cycle and read is coming after that, then we are 100% sure that what the data will be ABCD.
Okay.
But since this is not responded back and we are getting a read on the same clock cycles, we cannot say that surely I will get ABCD or 1, 2, 3, 4. We cannot say. It can either be 1, 2, 3, 4, or it can be ABCD. Both are true. This is a raw hazard. Talking about WO is right after right. So from the master, if you're sending on address 0000 with a value of ABCD, then you are again sending 0000 with a value of suppose DEF1. Okay. And then again you are reading a value of 0000. This is happening when you are getting a response back of it, then this transaction is coming when you have already got the response of this one. So the output of the memory should be DEF1. Okay, this is the write after write hazard. If a write and a write is coming for the same address, then second write will get the priority over the first one. Okay.
Okay, sir. Okay.
Write after read is don't care. You have performed a read. Let me clear it. Suppose if you perform a read on this, suppose on this clock cycle, okay,
Okay.
and write arrived over here. So this is, and the response of the write is arriving over here, and then the next clock cycle you are getting the response back, and read is coming somewhat over here. Okay, suppose this is the read time. So this is the read after write hazard. This is don't care. You will get the previously stored data or the next stored data
Okay.
for this. So raw is don't care. WO, you need to maintain the hierarchy that which address is coming last should be updated into the memory. And right after read, I mean raw is very important. Read after write. Read good if the transaction has been responded back and then you are reading it. After this you are reading it, then definitely you should get the data of the second one. Okay. Then Pankaj, out of these three hazards, you can have read after read modify write after read modify write read modify write after read modify write. So these are the different categories.
Okay.
Whenever you send a partial transaction, you will get a read modify write
Yes.
onto the slave. That we know already, right? So that we will cover in tomorrow class about AXI when I will teach you XI. So there we will cover everything.
Okay. Okay.
So Pankaj, it's clear, right?
Yes, sir.
Kul milake, when we get the response back, then only we can be ensure that okay, this transaction is committed and I will get the read data back of it. If the transaction has not been responded, then we might get the older data or the newly written data. It's totally depend upon the controller.
Okay.
Okay, guys. Any more questions from anyone? Any doubt regarding anything? Sanjeev?
Sir, this we'll cover in tomorrow's class, kya?
Yes. I will be covering this everything in tomorrow class when I will be teaching you AXI. Tomorrow class is of AXI.
Sir, okay, sir, my doubt was in how do we avoid this hazard, or is there any thing we do
Hazards are
for
never
controlling
avoided.
them?
Hazards are never avoided.
Okay.
Hazards can be controlled or we need to serve them. So controller should take care of this basically.
Oh, okay. It's not user dependent.
It's not user dependent. Clear.
Okay.
I have told you one thing to do, Molly. Suppose if I ask you to read AXI and then I suddenly ask you to read APB, okay? And then I will ask you, Molly, what you are studying. So ultimately you will send the second one. because I've told you to read APB at the last, so you will give me the response back as APB. Okay.
Yes.
If I ask you to read AXI, and in the meantime someone comes in between, and at the same time he asks you what you are doing, and I'm also saying what you are doing. Okay. If I ask at the same time, I'm telling you to write APB, write APB, and someone is asking what you are doing. So now it depends on you that how you are serving this hazard. Okay. That
So we will.
whether you will respond it with I'm reading AXI or I'm reading APB. Yeah, ma'am.
Yeah. So we
Yeah,
will put some priority for that case.
Right are always prioritized. Right always have priorities over read.
Yeah.
And your controller, the slave, should be able to handle it. Should be able to handle those hazards. Okay.
Yes. Okay, sir.
Because ultimately, what I have told you in this diagram, that suppose the frequency of this one and this one is different. So ultimately, slave is storing it somewhere over here, right? In the right FIFO, and there should be an address read FIFO. So it should know that what have come first and what we need to pop out and everything. So everything should be controlled by this. Okay, guys. I think all your doubts are clear, right?
Yes, sir.
So ultimately, if I'm teaching you from last 2 weeks, so you understood something, or it's just waste of time that we are doing?
No, sir, we understood.
I
Frankly,
understood
I'm
a lot,
asking.
sir.
Yeah, Vietnam friends. So is it good? We should continue these classes.
Yeah,
Yes,
sir.
Yes,
Only
it's
two of
good.
them want. Man, Wu, Nam, Dat, you are on mute, and Vith, Tran, you are also on mute. Tree, you are on mute.
We should continue, sir.
Yes, sir. Yeah, I think we should continue.
Okay,
Listen.
Yes, sir.
okay.
Yes, sir.
Okay, guys, so we'll continue tomorrow with AXI and all those hazards and everything I'll try to cover with exclusive and everything. Okay? But prior to it, Vietnam friends, spend some time and complete their assignment. So we will be playing with the ready, we will be accessing more than one slave, we will be calculating the performance. So it will give you a real-time idea, okay? That how an SOC works.
Yes, sir.
Okay,
Yes, sir.
guys. Then thank you. Have a nice day.